Good morning, students. So in previous lecture, we were discussing about the basic architecture of IoT. Okay, so I can call it as a foundation architecture for IoT. That was one M2M and IoT World 4. Okay, so in one M2M, okay, we observed that a block kind of architecture, right? But in case of IoT World Forum, okay, we were observing 7 different layers. Okay, each was having its own responsibility. Okay, so keeping them as a foundational architecture. Okay, we are designing a standard simplified IoT architecture for our rest of the discussion exactly. Okay, so what is this simplified IoT architecture? Okay, what is the advantage of using this? So this IoT framework, okay, that highlights the fundamental building blocks that are common to most IoT system and which is intended to help you in designing an IoT network. Okay, so this simplified IoT architecture, whatever we are going to discuss about, okay, so this will be considered as a foundational, okay, architecture or else the framework for the IoT network. Okay, so this framework is presented as 2 parallel stacks. Okay, so in next slide, you'll be finding what is the gesture of this particular architecture. Okay, so here we will be having 2 different parallel stacks. Fine. The first one we are calling it as the IoT data management and compute stack. So this is the first one. Then later, the second one, the core IoT functional stack. Fine. So in this module, we'll be discussing about IoT data management and compute stack, what they are exactly. So internally, how many different sublayers are available? Okay. So we'll be discussing regarding that. Okay. So this framework is consisting of a 2 parallel stack. Okay. One we are calling it as IoT data management and compute stack, and second one we are calling it as core IoT functional stack. Yeah. Okay. So next, the framework presented here separates the core IoT and data management into parallel and aligned stack, okay, allowing you to carefully examine the function of both the network and the application at each stages of a complex IoT system. Okay, so here, as we observe, okay, in World Forum architecture, okay, we were having a different layers, right, which was contributing its own responsibility over it. Is it? Okay, so here also we can observe some sublayers. Okay, it may look like 2 different stacks, but those stacks are having different rows. Okay, so in that rows, sub rows are available. So each and everyone is having its own responsibility. So they'll be contributing their own contribution for our architecture exactly. Okay, so later, so that we can examine. Okay, what is the network part? What is the computation part? What is the IoT part, like the teach part? Okay, such that we can go for a categorization of it. Okay, the core IoT functional stack can be expanded into sublayers. Okay, containing greater detail and specific network functions. So let's see that how we can do that. The applications layer of IoT network is quite different from the application layer of a typical enterprise network. Instead of simply using business application, IoT often involves a strong big data analytics component. Okay, so previously what all the architecture we discussed, okay, when it comes for the application part, when it comes for the application layer, okay, some computation only regarding the business application was like some decision we need to take. Okay, such type of application layer we have. But here we are having a computation kind of or else data analytics kind of computation available in our application layer. Exactly. So whatever the architecture we are going to observe in the next slide, okay, it is having a advanced kind of application layer who is not only taking certain decision, also will be analyzing the information. Remember this. Okay. So this was the brief introduction about the IoT architecture, simplified IoT architecture. So this is nothing but your simplified IoT architecture. So these are the 2 different stacks. Okay, so here core IoT functional stack. Okay, which is having application layer, communication network, then things. Okay, so together we are calling it as a things, but inside that we'll be having a sensors and the actuators. So we'll see, okay, in further topics and then what are the different sensors are available, what is the job of actuator and all. Okay, then IoT data management and compute stack. Okay, IoT data management and compute stack. So this is what this standard stack, okay, we are considering it as what we can call it as a classification. Okay, edge level will be available with things, means the sensors and the actuator. Okay, the network or as communication network, whatever we are having, that we are considering it as a fog level, and the application where the data analytics needs to be taken, okay, that we are considering it as a cloud. Just observe this. Edge we can consider as a mist. Okay, fog. Okay, like usually the mist will be over the leaf. Okay, over the ground. Is it right? Okay, but fog will be intermediate. Okay, and the cloud will be over that. Right? Okay, we are comparing our architecture with this kind of strategy, like edge, fog, and cloud exactly. Fine. So this is the gesture of our simplified IoT architecture. Okay, internally we are having sub layers. Okay, so regarding IoT, data management in complete stack, we'll discuss it later. So in this module, we'll be discussing about core IoT functional stack. Okay, so as I mentioned, the application layer is not so simple because it is having two sublayers. Okay, the sublayer one, we are calling it as analytics, who will be dealing with the data, whichever received by the network. Okay, so whatever the data received by this network layer to this application layer, that should be analyzed properly, whether it is necessary or unnecessary. Okay, based on that, we need to take the decision. So over that, we are having one more layer where the main application is going to run exactly. Okay, vertical specific applications. Okay, SCADA, MDM. Okay, a lot many others are available. So we'll be discussing regarding this in further module exactly. What is SCADA? What is MDM? Okay, many other also available. Okay, what are those application software? We will be discussing regarding. Okay, fine. Later. Then when it comes for communications network, okay, so here we'll be having four different layers exactly. Okay, this is at the bottom level, right? See, one thing you need to understand, it is the intermediate layer, so it need to communicate with the application layer, and also it should communicate with the things exactly. Okay, so for communicating with this things layer or the sensors and the actuator, access network layer will be helpful for us. Okay, the job of access network layer is what? We should establish a last mile communication link between the communication network layer and the sensors exactly. Okay, for that we are having different kind of network over here, field area network, LoRa. Okay, and apart from that, advanced kind of network also we have for LoRa WAN, we are calling it as PLC. Okay, so such type of field area network we are generating between this communication network and the sensors exactly. Then later, after establishing that, the information whatever we are receiving, that should be received through gateway itself. Okay, that should be received through gateway exactly. Then later, after receiving the information by these all sensors in this gateway, it should be communicated towards a higher level layer, right? Okay, for that we are using one more network called as what? Backhaul network. Okay, backhaul network is a network between the gateway and the upper layer, remember. Okay, so access network is the network between the gateway and the sensors exactly. Yeah, okay, fine, later. Now here in this network transport layer, so what are the protocols, what are the network strategies we are expecting to communicate with the application layer using the backhaul network that will be available. Okay, and here IoT network management. So this is what the layer will be using such type of a application. Okay, so we will be converting the received information from the bottom level. Okay, and it will be converted in a such a manner that which is expected by the application layer exactly. Okay, see, regarding this, we'll be having each and every chapters available. Okay, so over which we need to discuss in deep exactly. But right now, this is what the gesture of our IoT architecture exactly. I hope you don't have a doubt. Okay, so sensors will be the hardware which will be deployed in the real-time environment. Okay, how it will be classified and all, what all the different things we need to discuss regarding the sensor. We will be discussing in today's session. Rest of all regarding like communication network and application layer we'll be discussing in the next lecture. Yeah, okay. So now, yeah, we got the core IoT functional stack regarding that. So what I'll discuss now, okay, same thing I will be repeating over here. IoT network are built around the concept of things or a smart object performing functions and delivering new connected services. Okay, so this is what the job of the IoT network exactly. So these objects are smart because they use a combination of contextual information and configured codes to perform the action. Okay, so here each and everything is predefined. Like if you are receiving certain set of the data, okay, for that what will be the reaction, that is also already defined exactly. Okay, so according to that they will be performing the action. You see, if in case I will take the example of the AC. If the room temperature is below 16 degrees, AC should be turned off. Okay, or the temperature should be increased to 20 degrees. Okay, if that is so, like we need to train our system, or we need to define our system like, okay, if 16 degree happens, okay, then this should be the condition, or this should be the action to be taken. Okay, if 20 degree happens, so this should be the action taken. That's why we are calling it as a smart. Okay, when we are calling someone as a smart, okay, according to situation, if he is able to perform well, okay, then we'll be calling it as a smart, right? Same thing we are going to do over here. Okay, certain actions, for all the action we are performing using this layer, we'll see that in most cases, the things interact with an external system too. Okay, like external system is what? Environment exactly. Okay, it will be interacting based on the action. Okay, so report information that the smart objects collects. Okay, so it should be reported back whatever these things are sensing. So that should be reported back to the application layer. Okay, so that is the second job. Okay, to exchange with other objects. Sometimes this information will be exchanged with other things also. Okay. Then later the fourth one, to interact with a management platform. Okay. So these are the very important four things will be done by your core IoT functional stack. Okay. The management platform can be used to process data collected. Okay. From the smart object and also guide the behavior of the smart object. So this is what the general working principle of the core IoT functional stack. Okay, but we'll go in deep regarding like from the architectural standpoint. Okay, several concepts have to work together for an IoT network to be operational. Okay, as I discussed earlier, okay, we are having the things layer. At this layer, the physical device need to fit the constraint of the environment in which they are deployed while still being able to provide the information needed. Okay, so this is the job of the things layer of the sensors exactly. See, these sensors are physically exposed to the atmosphere or the environment, remember. Okay, so the thing is, we should be able to, our network should be able to secure those things. Okay, physical damage, if anything happens, we cannot handle it. Okay, we cannot take any precaution for that based on a network. But security aspects like hacking the sensors or flooding a false result or false information using the sensors, okay, such things can be avoided. So this will be done by things layer exactly. Then communication network layer, when smart objects are not self contained, okay, they need to communicate with an external system using the wireless technology. So this layer has four sublayers. See, the sensor, whatever it is sensing, right? So it is not having a potential or a capacity to store the information. Remember this. We may provide some set of buffer for temporary storage, but he is not able to store it for a permanent basis, and he is not having a efficiency to process the information. Remember this. So what we need to do, we need to transfer it to some other location. For transferring that, we need to be dependent on the network layer. So which is having total four different layers. So access network sublayer. Okay. So here we are calling it as a last mile IoT network. Okay, that is what. So here we'll be using the IEEE standards like 802.11ah, 802.15.4g, and LoRa. Okay, so these are the different access network what we can generate between the gateway of a network and the sensors exactly. Okay, then later gateway and backhaul network sublayer. Okay, as I mentioned, so gateway is the intermediate. Remember, gateway is the intermediate between the network and the access network. Okay, so whatever the information we are receiving from the sensor, it should come to the gateway first. From gateway, it should go towards the application layer exactly. Okay, so in gateway, we can deploy some security aspects. Okay, we can go for a verification, authentication of the link and all. Okay, lot many things are available. Okay, that will be discussed in further topics. Then backhaul network. So he is responsible for, as I mentioned, like information pass it for the higher layer. Okay, for that your backhaul network will be useful exactly. Then network transport sublayer. Okay, for communication to be successful, network and transport layer protocol such as IP and UDP must be implemented to support the variety of devices to connect. Okay, so this network transport sublayer is responsible for all the protocols. Okay, so we are just mentioning that IP-based, like internet-based protocol, and later we use a datagram protocol (UDP). Okay, but apart from that, we'll be using few more protocols available. Okay, so, like in upcoming topics, we'll be discussing that. Okay, and the last sublayer of this network layer is IoT network management sublayer. So additional protocol must be placed at a place to allow the head-end application to exchange data with the sensors exactly. Okay, so we need to include a few more protocols who should be able to convert the information received by the network, okay, to a format which is allowed by or which is supported by the application layer. Okay, then lastly, application and analytics layer. An application need to process the collected data, not only to control the smart object when necessary, but to make intelligent decisions based on the information collected. Okay, so we need to be in a position like, so whatever the information we get, that should be analyzed, over which we need to take certain decisions. For that, our application and analytics layer will be helpful in that. Yeah, so these were the brief introduction regarding the IoT simplified architecture. Now what we need to do, we need to go for a discussion regarding each and every layers. Okay, in today's session, we'll be discussing regarding the layer number 1, that is things, sensors, and the actuator. Okay, so we'll see what is this particular sensor means, what are these actuators. Okay, so in deep, we won't be going, okay, in model number 1, but in model number 2, 3, 4, such type when we go, okay, we'll be discussing each and every chapters regarding the sensors, regarding the actuator, what they are, how they are going to work, okay, what kind of signal they are generating, what kind of signal they are receiving, such type of discussion will be available. So here, we'll be discussing regarding the sensors, okay, what type of sensors are available, how we are going to classify them, regarding that we'll be concentrating. Okay, from an architectural standpoint, the variety of smart object types, shape, and needs drive the variety of IoT protocol and architecture. Okay, so there are many ways to classify small objects. So here we are trying to say like the network architecture or else IoT architecture, whatever we are going to use, that also depends on what kind of sensors or what kind of devices we are using. Okay, so this classification or this type, okay, can be decided based on object types, shapes, and needs. Okay, like it depends on the situation. Okay, so we'll see, or we will be discussing now such type of requirement, okay, or such type of option based on which we can classify what kind of IoT network we need to manufacture or what we need to deploy. Okay, so the first classification is battery powered or power connected. Battery powered or power connected. By the name itself, we can identify few sensors are like online, a mode of power supply should be available. Okay, means wired based power supply should be available. Okay, then we are calling it as power connected. Okay, if we are providing a backup battery for a sensor, okay, based on which it will be working for a long duration, okay, then we'll be considering it as a powered or battery powered sensor exactly. Fine. So now, if you want to deploy IoT network, then you need to decide first that the sensor should be powered. Obviously, without power, sensor will be waste, right? Without power, sensor cannot sense the information, right? So now, the sensor what we are deploying, first we need to decide that whether it should be battery powered or power connected. This is the one type of classification. Second type classification will be mobile or static. Okay, means this classification is based on whether the thing should move or always stay at the same location. Fine. See example, like while discussing some applications of sensors or IoT, I had mentioned one example that we are deploying some sensor for a cow or a cattle. Okay, so by which the farmers can identify the behavior of the cow and the health condition exactly, right? Okay, but in case of that, it is not a static. right? The car will be moving here and there, right? But if I try to get the information regarding the temperature of a room, then I should mount that sensor in a one fixed location. Is it right? Because the room will not move from here and there, right? Okay, so this is what the second classification, whether the sensor will be moving from one place to another or whether it will be just static in one place. Second classification. Then the third one will be low or high reporting frequency. What is this reporting frequency? This classification is based on how often the object should report monitored parameters. Okay, sometimes, example, okay, just an example. If you are trying to find the average temperature in the environment, okay, then like from morning to evening, okay, we need to control or we need to monitor or we need to get the information of the atmosphere. Yeah. Okay. Then later, what we need to do, we need to go for generating a average value of the temperature exactly. Right. Okay. Like daily once, if you are communicating back to the server, okay, then it will be okay. Okay. We won't be having any kind of issue. But if you are trying to analyze the temperature level of a machine, okay, then real-time information we are expecting. Then the reporting frequency will be more exact. So based on this also, we can go for a classification. Then later, simple or rich data. Simple or rich data. Okay. So this classification is based on the quality of data exchanged at each report cycle. Okay. A humidity sensor is a field may report a simple binary scale from 0 to 255, while an engine sensor may report hundreds of parameters. Okay, so here the parameters involved in that information, okay, matters exactly. Simple means what? Okay, fine. Like very little amount of information will be transferred. Okay, obvious. Like some examples. In case of here they have mentioned. Okay, in case of a humidity, we will be transferring some information like 0 to 255. Any one value will be transferred exactly. Okay, but in case of other aspects, okay, we need to transfer hundreds of information, hundreds of parameters. Okay, because for making a decision, okay, those 100 parameters are essential exactly. Okay, but during identifying the humidity, okay, 0 to 255, any one value will be transferred based on which we can identify, yes, this is what the humidity level in the atmosphere, that's it. Yeah, so such type of classification we can do. Then report range. Okay, so this classification is based on the distance at which the gateway is located. Very good example is your fitness band connected to your phone. Okay, fitness band connected to your phone. Okay, range always matters. Okay, the gateway, whether it is near, whether it is far, it depends. Then the last classification, object density per cell. Object density per cell. This classification is based on the number of smart objects with an similar need to communicate. Okay, remember one thing, object density per cell means for a one reason, if you are deploying many number of sensors, okay, over a given area, okay, connected to the same gateway. Okay, this also depends the classification exactly. Like sometimes for identifying the room temperature, 4 sensors are maximum, right? In the 4 corners of a room, if you are deploying the sensors, okay, then maximum, it's over. Okay, but saying in a factory, okay, we'll be having the huge location, or else in a chowdhury, okay, in a marriage hall, if you are trying to identify the temperature level, room temperature level, then 4 sensors are not sufficient. Then what we need to do? We need to go for deploying hundreds of sensors in the different corners, okay, different location, right? Okay, then we can get the actual temperature exactly. Okay, so these are the different classification over a things, over a sensors, what we can perform. Okay, so this is it for now, students. So next lecture, we'll be discussing about communication network layer. Okay, so over which like 4 different sub layers will be discussed in detail. Okay, thank you, students. So we'll meet with the next session.